According to two new research papers that identify seismic shock waves from impacts detected by NASA's now-retired Mars InSight lander, meteorites strike Mars 10 times more frequently than previously estimated. The new impact rate is surprising. The findings suggest that there are between 180 and 260 impacts on the red planet each year. These objects can be at least the size of basketballs, creating craters up to 8 meters 26 feet wide. The overall impact rate varies from 2 to 10 times higher than previous estimates, depending on the size of the impacting objects. Some of the newly detected impacts by InSight were also large. For instance, one study reports two significant impacts occurring 97 days apart, each capable of excavating a crater the size of a football field. We expected an impact of this magnitude maybe once in a few decades, or even once in a lifetime. But here we have two just over 90 days apart, said Ingrid Dauber from Brown University in a statement about the studies. Both studies used the SEIS seismometer instrument on InSight's seismic experiment for interior structure to detect impacts. InSight recorded seismic data for years, during which SEIS was active on the Martian surface from December 2018 to December 2022. Identifying seismic shock waves from impacts amidst other seismic activity on Mars is challenging, so Dauber's team compared the seismic data with images of new craters observed by NASA's Mars Reconnaissance Orbiter (MRO), correlating actual impacts with detected tremors. Dauber's team identified 8 new impact craters from MRO's images that caused Marsquakes detected by SEIS. 6 of these craters were in the vicinity of InSight's landing site in Elysium Planitia. The 2 large impacts occurring 97 days apart are the biggest new impacts on Mars in the history of robotic exploration. A second study led by Natalia Wojcicka from Imperial College London suggests, based on data solely from SEIS, that there are between 280 and 360 basketball-sized impacts each year. However, despite slightly different methodologies, the estimated impact rates in both papers independently confirm each other, increasing the reliability of the results. Detecting impacts this way is a new and significant capability because previously, planetary scientists could only identify new impacts by comparing before and after images of Mars' surface from orbit and checking for new craters. As you might expect, this method was very inefficient. Seismic data adds a new dimension to measuring these impacts. Moreover, these findings have implications that could extend to studies of all other solid bodies in our solar system. Planetary surfaces do not come with a timestamp indicating when they formed or were last resurfaced by lava. Instead, scientists estimate surface ages by counting the number of craters covering them. The more craters, the older the surface. We see a classic example of this on our moon. The ancient lunar highlands, which are nearly as old as the moon itself, are densely cratered, whereas the younger lunar mare, which are volcanic plains about 1 billion years younger, have far fewer craters. However, accurately dating planetary surfaces depends on correctly identifying impact rates, and the new data from Mars suggests we might not have been doing that accurately. If Mars' impact rate is higher than we thought, then some planetary surfaces might be younger than previously determined because their craters could have formed in a shorter time span.